I'm Alan Davis, a software engineer, a former cardiac nurse, and a senior lecturer in health data sciences at the University of Manchester. My goal on this channel is to make health data science, AI, and digital health understandable for clinicians, researchers, and anyone else who's interested in learning about this technology. A data frame in Python is a two-dimensional data structure that organises data into rows and columns. It's similar to a spreadsheet or database table and is often used when working with structured data. Access to data frames is most commonly provided through the Pandas library in Python, although other options are also starting to emerge. Some of the features of data frames include the ability to store data in labelled columns. These columns also allow data to be stored as different data types. It's built on top of some of the more lower level data structures which have been optimized for performance, particularly around merging, sorting, grouping, aggregating data. So let's take a look at a simple example of a data frame. Here we have a very simple data frame which just has 5 rows. It's organized into a couple of columns which include the name of a patient, some ID number, the ward that they were admitted to, the date of their admission, the time of their admission, and some sort of early warning score. We can access individual columns in a data frame much like we can access data in a dictionary by using a key. So in the square brackets and in quotation marks we include the name of the column that we want to reference, in this case the name column. This will return all of the items in that column. We can also select multiple columns, so we use a double set of square brackets and separate each of the column names by a comma. In this example we're returning the name column and the early warning score column. We can also subset data based on specific conditions. In this case we're returning all of the rows where the early warning score is greater than or equal to 2. We can also sort the data in a data frame. Another powerful thing we can do with data frames is we can actually create additional columns. Sometimes we can just add labels, or we can create columns from some amalgamation of existing data or computing some new results. In this example we're going to create a new column called high risk, which is going to contain true or false for any of the early warning scores that are greater than or equal to 2. Some other commonly used features that people often use with data frames are the ability to view the head of the data. So rather than opening to output the entire data frame, especially if it's got many rows, you can look at the first so many records of that data. There's also a shape option that returns the rows and columns of the data frame, so you can see what you've got to work with. The info method returns the column types and any missing data. The describe method returns summary statistics of those columns, and you can extract or select different columns based on their label or their position. Let's look at some examples of how we can actually implement data frames in Python. So let's say we had this dictionary here with admission data. It has key value pairs for several different data items. We can actually turn this admission data into a data frame. So we can access this in the usual way as we would with any dictionary. We can put the dictionary name and then we can put the key and it will return the values for that particular key. Importantly, if we're going to create a data frame, we have to have the same number of values. So essentially each row has to have the same number of items in it. So we'll go ahead and import the pandas module as PD. That just saves us writing out pandas every time, so it's a shorthand reference. And then we'll create a data frame using the Pandas DataFrame constructor, passing in our admission data dictionary. And this will convert that dictionary into a data frame object. And we can print out that data frame with the print function. And you can see now that we have the columns and we also have row indexes as well, starting from 0. Another alternative to pandas that's gaining in popularity is the polars library. So let's go ahead and import the polars library as PL. So Polars is very good when you're dealing with large data. It's quicker than Pandas and can process larger data more efficiently. So it's very useful if you've got larger data sets. So many of the examples that you'll see will indeed involve the Pandas library. But you can see if we print out this, we get a lot more information. It prints it out as a proper kind of table, giving you the actual data types for each of the columns. So you can see that the first several columns are all strings and the final column is an integer. So for this example, I'm going to use an IDE. I'm going to use the Spider IDE that we can use for running and executing Python programs. So I've got this admissions data file, the CSV file, and I'm just going to open this as a spreadsheet so you can see what that looks like. So it's got about 50 so rows. It's got details of patient names, their ages, admission dates, presenting complaints, the time that they spent in the department in minutes, and the outcome, whether they were admitted or whether they were discharged home. So we can open this kind of data inside a data frame. So we wouldn't typically create our own data set from scratch using dictionaries. That's good for simple examples, but when we want to use real data in the real world, we tend to import that data from a file such as an Excel file or a CSV file or another kind of file into a data frame. So the first thing I'm going to do is go into the folder that my data is located into. So my data is also in a subfolder called data, and it's called admissions.csv, comma separated values. So I'm going to go ahead and create a new Python file inside the same folder as the folder that contains my data. And I'm going to call this file analysis.py. So there we have our analysis.py Python file and our data folder. So let's go ahead and import the Pandas library. So I'm going to import Pandas as PD as usual. And then I'm going to open our CSV file into a Pandas data frame using the read CSV method. So read underscore CSV, and then I pass in the name of the data file. And you can see the IDE is suggesting what that input should be. So as you can see here, I've called it admissions.csv. So I need to use the same file name here, placed within quotation marks. So let's go ahead and run it and see if it does indeed import our data. So I save my file and hit the run button, and you can see we get some kind of error here. So it's telling me that there's no such file or directory. And this is because the data file is actually in a different folder. It's in a data folder. So I need to make sure that I specify the path correctly. So I need to write data because it's in the data folder, and then a slash, and then the name of the file. And when I run it again, you can see there's no error in the output. We can print the data frame, and we can print the head of the data. So that's just going to give us the first few records of the data rather than outputting the entire data frame. So you can see when I hit the print button, I get the first 5 rows. That just gives me an idea of what the data looks like. We can also use the tail function if we want to see the last few rows of the data. And you can specify a number of rows in between the open and closed brackets as well if you want more than the default 5 rows. We can also use the info method, and that gives us some information about the column names and the data types, the D type. So if there's strings, floats, integers, and also it tells me the number of non-null entities. So is there any empty data in that particular column? I can use the columns parameter here, and it will show me the name of all of the columns in my data frame. And of course, when you're accessing data in a data frame, you need to specify the columns exactly as they appear, including any capital letters. We can use the shape option here to see the shape of the data, the number of rows and the number of columns. So it's telling me here that I have about 50 rows and 6 columns. And of course I can access certain elements of the data frame as well. So if I want a particular column, I can specify just that column and it will return that column. So in this case, the name column, and I get just the column of names. If we want multiple columns, we need to use the double square brackets and then just list the number of columns separated by a comma. So in this case, I'm going to have the name and the age column. and now it returns the name and age column. So let's subset some data to show you how that works. So let's create a new variable called, say, patients over 50. And here I want to extract all of the data for any patient that's over the age of 50 years. So here I'm going to specify a new variable called patients underscore over 50, and I'm going to extract from initial data frame the age where the age is greater than 50. And this is going to give me a new data frame object with that subset of data. And here you can see that we now have those particular patients extracted. And this is very useful if you've got large data sets. Imagine a data set with millions of rows. Perhaps you only want to look at a certain type of patient, maybe females over the age of 60 with a particular kind of cancer. This is where you would subset that data. So you're not working, with much slower, larger volumes of data. You've got a concise subset of the data that you're actually interested in. And of course you can make more complex conditional queries as well. So in this case, I'm going to extract all the patients over 80 years old, but that also have an outcome of being admitted. So I'm only interested in the patients that were admitted that were over 50 years of age. So this is a dual condition. So they have to be over 50, and the outcome label has to be equal to admitted. And again, we use the double equal sign for equality. And here you can see I now have a smaller subset of those patients over the age of 50 that have actually been admitted. We can also do things like counting the missing values in a particular column. This is important because if you've got a large portion of missing data, you have to adopt various strategies to deal with that. You might choose to remove the rows or to impute some value like the mean or median, for example. So here I'm going to look at the sum of any of those cells that have no values inside them, or as Python puts them, it uses nan, not a number. So here we can see for each of those columns the number of missing data items. And this is part of the data cleaning process. So you may have a pipeline of cleaning and filtering your data before you actually analyze that data set. And it's quite common to keep a copy of the original data before you start the cleaning process, and then whittle down to through your pipeline to kind of clean it in various ways. So that might be removing missing data or imputing some value. It might be getting rid of any columns you don't need and subsetting the data so it's exactly the version of the data that you want to work with. So in this example, I'm going to get rid of the missing values in the time in department column by filling those NA values with the mean of that column. So I'm simply going to use the fill NA method, and I'm going to use it to fill those missing values with the mean of the time in department. So it's going to take the average value of that column and put that into the missing spaces. And now if we look at the number of missing items in the column, you'll see that that's gone to 0 now. Of course, this is just an example. The actual decision of how to deal with missing values can be quite complex depending on the nature of that missing data. So this is just to show you the kind of functions you can apply, not really to discuss the strategy of dealing with missing data. It's a bit more nuanced. Other common things that you might want to do in the data cleaning pipeline include things like removing any duplicate values and perhaps recoding or relabeling some of the data. Certainly if it was collected maybe from different sources or it's presented in slightly different ways, you might want to standardize that. You might also want to produce some summary data as well. So in this case, we're looking at the counts of different items in the outcome column. So we want to know how many people were discharged home, how many people were admitted, and perhaps any missing values as well. So this is a quick way of summarizing that data as a small table. The Pandas library also includes some quick plotting functions as well. So if we use the hist method for a histogram on the outcome column, we can see that it produces a histogram showing us the number of people that were admitted or discharged home. This is very good for exploratory data analysis, perhaps not for publication quality visualizations, but if you want to quickly look at some of the data and look at that in visual ways. In the Pandas, in the Spider IDE as well, which is quite good for data science, we've got a variable explorer, and we can open our variables and view them, especially data frames. It will show us those in a tabular structure. So it's quite good for having a visual look at what that, if you're used to looking at data in sort of spreadsheets or tabular format, it's very good for that sort of sense checking. You can open it and view it as a table. So in summary, data frames are widely used in data science, especially for data that lends itself to a tabular structure. The data frames allow for rapid processing and subsetting of data, and they often form part of that data processing pipeline. So if you are interested in learning to code, I've actually written some books on the topic, on learning to code and mathematics as well for clinical and health data sciences. So these are really written for people that are coming from a non-engineering and maths background, computer science background. They're for people coming from a health and social care background that haven't got that sort of formal mathematics and computing training that, you know, people that maybe come from that engineering sort of disciplines have. So it doesn't assume any prior knowledge and sort of starts with the fundamentals essentially. And the examples are in both Python and R, so you can pick which one of the two most popular languages for data science that you'd like to use. And if that's of interest to you, you can find links in the description below. Also, if you prefer something online, then I've got a free online short course in learning to code for people coming from healthcare background, also linked in the description. At the moment, this is just available in Python, but an R version is coming soon. In future videos, I'll discuss these roles in a bit more detail, as well as take a bit of a deeper dive into some of the technologies used and actually look at some examples of how we can apply some of these tools in practice.